Hello friends, myself Praveen Kajri. Welcome to the video classes. So in this class we will understand the meaning of precision and accuracy and then the meaning of significant figures. So let us start with the precision and accuracy. So in order to understand the meaning of a precision and accuracy, first we have to know some basic terms, right? So every measurements is associated with a certain amount of errors. Okay, so every measurements associated with errors. So for example, if I ask to measure a particular quantity by different peoples, then those peoples are reporting different values. Each person is reporting different value for the same measurement. So why it happens? So it may be because of the personal error, because of the inability of that person to read that measurement, right? That is known as a personal error. Because of the personal error, the measurement may be wrong. So another possibility is there may be a defect in the instrument, measuring instrument. Then also we can find some errors, right? So if all the possible errors in that measurement are minimized, it may be personal error, it may be instrumental error, it may be any kind of errors. Okay, if you minimize all possible errors in that measurement and if you report the value for that measurement, that is known as a true value. Okay, so what is that? That is known as true value of that measurement, true value of that measurement. So let us take a particular matter, let us find its mass by minimizing all possible errors during the measurement of that mass. Okay, if it weighs 2 grams, let us take it is a 2 grams. So this is the true value of that mass of that matter, right? So now same thing, if I ask to measure the mass of that matter by different students, student A, student B, student C. If I ask student A to measure the same mass of the same substance, okay, so he is going to report 2 measurements. In the first measurement of the mass, the value is 1.95 grams. In the second measurement, the value is 1.93 grams. Right? The 2 sets of values of measurements he is reporting. So these 2 values are known as values of measurement. What is that? Values of measurements. Right. So now we have to find the average of these 2 measurements. That is first measurement plus second measurement, value of the first measurement plus value of the second measurement divided by 2. You will get average of the 2 measurements, average of the values of measurements, right? So this is nothing but average value. So these are the average of different values of measurements, average of these 2 values of measurements, right? So the value is 1.94 grams for the student A. The same measurement is asked to perform by student B. The value is 1.94, 2.05, and the average value of these 2 are the values of measurements, and average value of the measurement is 1.95 grams, 995 grams. Student C is reporting the values 1.99 grams, 2.01 gram, and average value of measurement is 2.000 grams, right? So true value, we know the meaning of true value, we know the meaning of values of different values of measurements, right? And average value of measurements. By knowing this, now we can understand the meaning of precision. So what do you mean by precision? precision is the measure of closeness of the different values of measurements. So let me write that. Precision is the measure of closeness of different values of measurements. So here for the first student, two values of measurements, whether they are close to each other. So that is what the precision is. We have to look for the values of measurements. If they are very close to each other, then we say that measurement is a precise measurement. Right. So in case of first student, 1.95 grams, 1.93 grams, only 0.02 grams is the difference between these two measurements, between the values of measurements. Therefore, we can say these two values of measurements are very close to each other. Right. Therefore, this measurement of the mass of the substance whose true value is 2 gram, and the values of measurements are very close to each other. The values of measurements are very close to each other. Therefore, this measurement is a precise measurement. Precise measurement. Right. So next student B, the values of measurement 1.94 grams, 2.05 grams. What is whether these two values of measurements are close to each other? Just observe this: 1.94, 2.05. There is 0.11 gram difference is there between these two measurements. That is the huge difference. That is the big difference between these two values of measurement. Therefore, these two measurements are not precise measurements. Not precise measurement. Right. What about the third student? The first value of report is 1.959 grams, 2.01 grams. Right. What is the difference between these two? Approximately that is equals to 0.02 grams. So that means these values of measurements are also very close to each other. That is what the precision is. Precision is the measure of closeness of the different values of measurements. Okay. Out of these two values of measurements, these two values of measurements are very close to each other. Therefore, this measurement is also precise measurement. Right. So now we have to understand the meaning of accuracy. Accuracy is the measure of closeness of average value of measurement with the true value of the measurement. So what is that? Accuracy is the measure of closeness of average value of measurement. Average value means you have to look for this column with the true value, that is 2 grams. That is 2 grams. So if there is a closeness between the true value and the average value of measurement, right? So these are the average value of measurements by the student A, student B, student C. If this is close to true value, then that measurement is known as accurate measurement. Here 1.940 gram is not equals to 2 grams. That is not in agreement with the true value. Average value of measurement is not in agreement with the true value. Therefore, this measurement is not a accurate measurement. So it is not accurate. Right. So next measurement, student B reports the average value of measurement as 1.995. Whether it is in close agreement with the true value? No, there is a 0.005 difference. Therefore, this is also not accurate measurement. It is not accurate measurement. So what about third one? So average value of measurement is 2.000 grams. Whether it is in agreement with the true value? Yes, they are equal to true value. So they are equal to each other. Therefore, precision, this measurement is also accurate measurement. So precision means it is the measure of closeness of the different values of measurements. So you have to look for the different values of measurement. If they are very close to each other, then that measurement is a precise measurement. In case of accuracy, if you want to check the accuracy of the measurement, you have to look for two values. One is average value of measurement and the true value of measurement. So if average value is in agreement or close to the true value, then that measurement is known as accurate measurement. So then what is true value? True value of measurement is the value obtained by minimizing all possible errors of measurements, right? So that is known as true value. So we can also understand this precision and accuracy by taking a simple example, that is shooting of bullets to the target sheet. So by using that we can understand the meaning of precision and accuracy very easily. So let us take a target. Here a person A is asked to shoot 5 rounds of bullets on this target. So actual target point is this one. This is our true value. Actually he has to shoot the rounds of bullets, 5 rounds of bullets at this point. So first person is shooting all the rounds at this point. He grouped all the bullets at this point, right? So they are very close to each other, but that is not close to the center of the target. That is our true value. Therefore this shooting is a precise shooting, but not accurate, because this grouping is not close to the true value or the center of the target. So if a person B is asked to shoot 5 rounds of bullets to the center of this target, then this is our true value. Here he has to shoot all the 5 bullets, but what he is doing is he is shooting the bullets randomly over all the sheet of the target. So therefore they are not grouped at one point. That means they are not close to each other. That means this is not a precise shooting. It is not precise. Whether that grouping is very near to the true value or the center of the target? No, that is also not in this case. Therefore this is also not accurate shooting. It is not a precise shooting, nor it is a accurate shooting. So third person, if a person C is asked to shoot 5 rounds of bullets to the center of this target, then he is shooting all the bullets. So here all 5 bullets are hitting the target and they are grouped. Therefore all the all the bullets are hitting very close to each other. That means this shooting is a precise shooting. So this is precise shooting, and also the grouping is at the center of the target, right? So therefore this is also accurate shooting. It is a precise and accurate. This one is only precise but not accurate. This is neither precise nor accurate. This one is precise because all the bullets are hitting the target very close to each other. Therefore that is a precise shooting. Another one is that grouping is also at the center of the target. Therefore that is also accurate. So this is one more way of understanding the precision and accuracy. Right, now we have to understand the meaning of significant figures. That is significant figures. In order to understand the meaning of significant figures, we must understand this example, right? So I am using the scale, centimeter scale. This is one more centimeter scale. In this centimeter scale, we have up to 0 to 46, 146 centimeters, 147 centimeter, 148 centimeter, right? So in between that 146.5, this is 147.5. So in between that 0.1 digits, 0.1, 146.1, 0.2, 0.3, 0.4, 0.5. So this is the scale, this is one scale. In this scale, again the same scale. So from 0 to 146, 47, 48. So there is 146. So we have divisions, 0.01 divisions. So in this case, we have only 0.1 divisions. Okay, in this scale. In this scale, we have 0.01 scale, division. 0.01 centimeter is one division. This is one division, right? So if you measure the length of this wire by using this scale, the reported value is 146.7 centimeters. 146.7 centimeters, right? The same length is measured by using the different scale which is having 0.01 divisions, right? So if you do that, the reported value is 146.7. Along with that, we have to write 0. We are not supposed to stop by rating 146.7 if you use this scale of measurements for the measurement of length, right? So 146.70 we are reporting, not 146.7. That means what this 0 indicates? That indicates that so there is a possibility of further measurement. So there is a divisions even after a 0.1 division, right? So you can also report a 0.7. There is some more measurements after that. So that is what the indication of writing this 0. So that means this 0 is significant while writing this number. So if you are writing a number, this 0 is significant. That is important. If you stop writing only 7, that indicates that scale is having only 7.7. After that, there is no divisions between a 0.1 measurements, right? So that is the indication. So then what is the significant figures? So significant figures are the number of meaningful digits. Meaningful digits in the given number. Significant figures means what? Are the number of meaningful digits. Meaningful digits in the given number. For example, this is the measured value by using this scale, 146.7. How many meaningful digits are there in this number? 1, 2, 3, 4. All digits are meaningful in this number. Therefore, significant figures in this case is 4. What about this? The number of meaningful digits, 1, 2, 3, 4, 5. 0 is also significant in this case. 0 is also a meaningful digit. That indicates that there is a further possibility of measurement even after 0.7. Right. So therefore, how many significant figures are there in this value? 14670. That means 1, 2, 3, 4, 5. 5 significant. In this case, only 4 significant figures. In this case, 5 significant figures are there. So what are the rules to find the significant figures in a given number? So that we will discuss here. Rules to find the significant figures. So first rule is, all non-zero digits are significant. So that means if the measurement is 1, 4, 5, 6, 7, 1, 4, 5, 6, 7, then number of significant figures according to this rule, all non-zero digits, there is no zero digits in this number, 1, 2, 3, 4, 5, significant figures are 5. So 1, 7, 8, 9, so number of significant figures in this case is 4, 1, 2, 3, 4, all non-zero numbers are significant. So 8, 8, 8, 8, 8, 8. So in this case, number of significant figures is equals to 1, 2, 3, 4, 5, 6, 6 significant figures. This is the meaning of the first statement. All non-zero digits are significant. So second one is zeros in between non-zero digits are significant. What it mean? So 1, 0, 6. This 0 is in between a non-zero digits. Therefore, this is a significant 0. That is the significant. So therefore, that means it is having a meaningful. So that is also a meaningful digit. Therefore, significant figures in this case is 3. 1, 0, 0, 0, 0, 1. Significant figure in this case is all zeros, the zeros in between a non-zero digits are significant. Therefore, 1, 2, 3, 4, 5, 6. 6 is the significant figure. So 1, 7, 8, 0, 6, 5, 0, 1. So this is 1 0, this is another 0. Those two zeros are in between non-zero digits, right? Therefore, they are significant. Therefore, number of significant figures in this number is 1, 2, 3, 4, 5, 6, 7, 8. So this is the meaning of second statement. Third rule is zeros preceding to the first non-zero digit are significant. Zeros preceding to the first non-zero digit. For example, 0, 0, 1, 0, 1, 2, 5. Right. In this example, 0 preceding means what? Preceding means the number which comes first. The number which comes prior to something, that is known as preceding, which comes first. Right. So zeros preceding to the first non-zero number. Which one is the first non-zero digit in this case? 1 is the first non-zero digit. Right. So 0 preceding to that, 0 preceding a first non-zero number digit. So these are insignificant, they are not significant. Therefore, how many significant figures are there in this number? 1, 2, 3, 3, because 0 is not significant. Zeros preceding to the first non-zero numbers are not significant. So another one is 0, 0, 1. Number of significant figures in this case is only 1. So another example is 0.006. Significant figures in this case is, again the rule, you have to invoke the rule, that is zeros preceding the first non-zero number is 6. Zeros preceding, zeros which comes first to the first non-zero number are insignificant. Therefore, significant figure in this case is only 1, that is 6. Right. So find the significant figures. Number of significant figures in this number: 0, 0, 1, 0, 8. Right. So zeros in between a non-zero numbers are significant. Zeros which precedes the first non-zero numbers are insignificant. That means these two are insignificant, this is significant. Right. Therefore, significant figure in this number is 1, 2, 3, 3. Right. So fourth rule is zeros written right to the a non-zero number, non-zero digit are significant. Significant if they are present on the right side of the decimal point. So that means let us take 1.0, 1.260, right. So here number of significant figures, what the fourth rule says is zeros written right to the non-zero digit, zeros written right to the non-zero number, non-zero digits, they are significant. When they are significant, if they are present on the right side of the decimal point, if they are present on the right side of the decimal point, right. Therefore this 0 is also significant. Therefore number of significant figures in this number is 1, 2, 3, 4. Take one more example, 0.001060. In this case, according to second rule, zeros in between non-zero digits are significant. This is significant. Zeros written right to the non-zero numbers are significant if they are on the right side of the decimal point. Therefore this is significant. Zeros presiding to the first non-zero number are insignificant. Therefore these three zeros are not significant. That means all, and one more rule is all non-zero numbers are significant. That means this one and this one is significant. Therefore number of significant figures in this case is also 4. So this is the meaning of fourth rule. Fifth rule is zeros written right to the non-zero number, non-zero digits are insignificant, are not significant. If there is no decimal point in the given number. What do you mean by this? Let us take an example. Let us take 100. So here zeros written right to the non-zero digit, they are not significant. These are not significant. When they are not significant, when there is no decimal point in that number. So there is no decimal point. We are not writing any dot here, right? Therefore these are insignificant. They are not significant. Significant figures in this number is only 1, right? So 5000. Number of significance in this, significant figures in this also 1. Only 5 is significant because zeros written right to the non-zero digit are insignificant if there is no decimal point in that number. That is the rule, right? So let us take sixth rule. Sixth rule, zeros written right to the non-zero digit are significant. Significant if there is a decimal point in that number. What do you mean by this? So 100, in 100 the zeros which are written right to the non-zero digit are insignificant if there is no decimal point. If I write 100 point, so we are not supposed to write any number like this, it has no meaning. Still, for convention, if I write like this, for understanding purpose, if I write like this, right, so then because of this decimal point, these zeros also becomes significant. So in this case, number of significant figures is equals to only 1. In this case, number of significant figures is equals to 3. Zeros are also significant in this case. So 7th rule is exact numbers has infinite number of significant figures. That means 2 ball. So it can also be written as 2.00 up to infinity 000. So that means significant figures in this is infinity, right? Similarly, 5 dozen. So in this case, this can be written as 0.000 up to infinity. So that means significant figure in this is also infinity, right? So what the 7th rule says is exact numbers like 2 ball, 5 dozen, 1 meter, this is exact number. So these all have infinite number of significant figures, right? So here we discussed the meaning of significant figures. Significant figure means the meaningful digits that are present in a given number, right? So the rules to find, 7 rules to find the significant figures in a given number. First rule is all non-zero digits are significant. Second rule is zeros in between non-zero digits are significant. Third rule is zeros preceding to the first non-zero number are insignificant. Fourth rule is zeros written right to the non-zero digits are significant if they are on the right side of the decimal point. Fifth rule is zeros written right side to the non-zero numbers are not significant if there is no decimal point in that number. Sixth rule is zeros written right to the non-zero digits are significant if there is a decimal point in that number. Seventh rule is exact numbers have infinite number of significant figures, right? So in this class we have discussed the meaning of accuracy and precision, and then we discussed the meaning of significant figures, and then the rules to find the significant figures. So in the next class we will understand the addition, subtraction, multiplication, division of significant figures, and then how to round off a given number. So thanks for watching the video. Please share this video with the students in need. Thank you so much.